So today I'm at Quantum Design and Technologies Incorporated here in Edmonton, Alberta with Bill Jackson, and he's going to be helping me to 3D scan this antique window, and we're going to talk about the process. Okay, so
I've got this all set up at its highest resolution of 0.02 inches, and it's all ready to go.
Okay.
And I've set up the window here on this little makeshift stand. I've sprayed it with a reflective coating so that the scanner can more easily see the surfaces. And I've also added these little reflective dots around the window, which just help the scanner maintain position and know where it is.
Okay, and this reflective stuff, could you show it to me?
Oh, certainly, it's right here. So we used this one here, which when sprayed on, dries and easily cleans off, but evaporates on its own after about 4 hours.
Okay.
And it just makes it so that everything is much more visible to the scanner.
Okay, and then this is the scanner that we're going to be using?
And it's got multiple cameras and lights for identification.
Okay.
And it'll make a lot of big, flashy, bright light when it's scanning.
Is this something that your company developed, or?
No, this is a product called a Peel 3D scanner. Okay. The company is called Peel 3D, and yeah, it is used for scanning very small things and very large things.
Wow. So we're still not at the point where the average person that has a 3D printer at home can afford to do this on their own, hey?
Well, there are pieces of equipment you can buy that will let you do very small things, but this is very versatile for us. We have scanned things as small as this window and as large as earth-moving scoops and Jeeps and trucks and things.
Wow. So why would you want to scan a truck?
So if you want to add things to the truck with or repair parts of the truck and you want to make new parts that fit just right, it's a very quick and easy way to do so, especially if you don't have drawings or schematics.
Wow, crazy.
This is all good to go. So I'm sorry to say I'm going to have to be able to see that screen behind you there.
Okay.
So it's going to be a little bit tricky here.
So how about I move the chairs out of the way?
Sure. Oh, I got to head start first. And should start picking it up. Where are we here? Oh, there it is.
Okay.
You have to maintain a pretty specific distance to the part, and you can't move too quickly.
Okay.
And you can see it's starting to generate a point cloud on the screen behind me.
Well, I can't see that from here, but I trust you. We'll go look at the screen after you're finished.
Sounds good.
So basically what you're doing is you're just going around at every direction?
Yep, I just slowly move around, I change angles, I go up and down, and I make sure that it is picking up every point that it can as I go along.
So what's the most unusual thing you've ever scanned here?
The most unusual thing for me was having to go to a heavy equipment operator's and scan a 10-foot tall earth-moving bucket for a great big bulldozer, and having to cover the entire bucket in these little reflective stickers, and having to spend quite a while doing that. That was quite arduous.
So just getting it set up was probably the most difficult part of it, eh?
Yeah, and then they're just spending time moving slowly, making sure that everything is working just as it can, making sure the machine doesn't lose place.
Yeah.
All that sort of thing.
So how far away do you think we are from the average guy who owns, a 3D printer to be able to do this kind of technology himself?
Oh, I don't know. I'm sure that there are DIY and crude solutions or affordable solutions that will get you close enough right now, but something with this accuracy and versatility is maybe still out of the price range of a lot of people and will be for a little while.
Yeah.
But
I have watched a few videos on YouTube where they're now using like the iPhone, I think the iPhone 14 or
right, the LiDAR scanner in there, yes.
Yeah. But I've also seen that there's questionable quality issues with doing that as well,
yeah,
right?
I can understand that thing.
Yeah. So I'm just going to step out of your way, and I want to look at what is actually coming up.
So this is the sort of interim screen that they give you. It is not the full detail of the scan.
Okay.
It's just sort of a rough idea, so you can see that you hit parts and you know that you're not missing anything and all that sort of thing.
So part of it is the box that it's sitting on, and you can
Yes,
see
exactly.
the top
So
is the window.
There's always model cleanup after the fact, right?
Yeah.
This is just getting everything into the scanner so that it knows what to start with.
So what kind of file will it create? An STL file? Or
I
will
believe
it...
it's an STL. It's a very dense one. Lots and lots of triangles.
Okay.
And then you sort of have to spend some time optimizing and
So we
preparing.
could we print this file on either a resin printer or
Absolutely.
what's the other kind? There's a resin printer
FDM or filament.
or filament. Okay.
Yeah. So this one, we have a resin printer here, and we have a filament deposit, but we don't use it as much.
No.
But so I've just about got it covered here.
Okay.
And I'm now just sort of making sure that it's got as much data as it can.
Okay.
Just getting.
Did you go from the very top to make sure that you
Why
got
not give it one more hit just in case?
Yeah. It's really important to me that when we recreate this window, that it's as close as possible to exactly the way it's supposed to be, right?
Right. So I'll do.
Second, go ahead.
So this is just sort of the preview version that gives you, just to give you an idea to make sure, so you can see, like for instance, these holes are where it didn't see the case that it was sitting on and whatnot. And that's in case you want to make sure you hit everything.
Okay.
But once I hit finish, we'll just do its little calculation here and make sure everything's good.
That was incredibly quick. Like that took what, about 4 or 5 minutes tops?
Yeah, so this machine is quite efficient and fast, and it can, which is why it's so good for large things as well, right? But
I can imagine. How long did it take you to do, like, say, for instance, a vehicle?
That's a several hour process, because you also have to make sure that you're working in parts as you move along, and make sure you're getting everything. And it's a huge file and all that kind of stuff. But so, yeah,
incredible, just incredible.
Okay, so it's done sort of refining and preparing the final scan. You can see all the little triangles it did for all the little points that it found all along the way.
Okay.
And there will be some repair that has to be done, of course, to the scan. There always is. But we can clean up the edges, make sure that everything's as straight as the original, or as crooked as the original as it needs to be, and just make sure there are no holes or missing surfaces.
Okay.
And then we will be able to 3D print it.
Wow, that's just incredible. Like, look at how accurate that is. That's amazing. Can I see the back of it?
Sure, just a moment. Let me zoom out a little bit.
You can see where it's indented, where the actual picture frame glass window will go inside.
Yeah.
Wow.
So
that is just like amazing to me. Just absolutely amazing. So how long will it take you? I mean, you do this all the time, but how long would it take you to clean that file up to make it usable?
Oh, not too terribly long. We'll put it into a CAD software like Fusion, and we'll just sort of do a little bit of surface repair here and there. I can't imagine it taking much more than an hour or so.
Wow.
And then I will then, of course, make sure that you get a good look at the final file before we print anything, just in case, and then we'll go from there.
Okay. That's just incredible. So for your 3D scanning needs, it's Quantum Custom Design and Manufacturing here in Edmonton, and they're located on 163rd Street and 132nd Avenue. And I don't see any reason why anybody worldwide, if it's a small item, can't get a hold of them for a quote. Here's their website, and here's their contact information. Of course, if you're calling from outside of Canada, you have to put a 1 before that phone number. But definitely, they're willing to take on small projects. So I'm sure there's lots of people that restore antique dollhouses and miniatures that have problems that they just can't solve without this type of technology. So this is just an amazing way for us to be able to preserve history and be able to do something. I mean, once this window's painted up, you won't be able to tell that it wasn't made from tin. I mean, it certainly won't be able to be told with the naked eye anyways. Well, thank you very much, Bill, for doing this with me today. That's just amazing. So once again, here's the front of my dollhouse. And as you can see, I do have the big square window that's over the door. And I do have the window that's to the left of the little tiny door there. But the other 3 windows, sadly, are missing. So that's why I was doing this 3D scan, because I need to recreate these 3 missing windows, which I think is just going to be working out perfectly by using this new technology. Yeah, it's kind of crazy to think that a 120-year-old dollhouse could be fixed and repaired with this new technology. So I can't wait to see what they look like printed. I'm really super excited. If you haven't already subscribed to my channel, please consider subscribing. It's free to do so, and it really does help my channel grow. Please hit the like button, and I love reading your comments. And our next installment on this little journey, I'll get Kevin to do some filming for us as well. So yeah, this is really exciting. I can't wait to see these windows. That was probably one of the most interesting things I've ever done, was watch that 3D scan. Thank you so much to Quantum for doing this for me. Wow, that was a really interesting morning I had. Well, once again, everyone, I hope you all have the best day ever.